This is the sixth and final note of Unit 3. So most of this is going to be review, and then we are going to just kind of apply this to some word problems so you have some background knowledge on applying these concepts. So the first thing here says, how is the equation 2x minus 4x minus 16 different from previous equations you have factored? So this could be different in a couple of ways. So although we have seen a couple examples where we would have to common factor first, this is one of those examples, right? So it could differ because we have to common factor first. The other thing that's a bit different is we'll notice that both the b and the c term are negative. So that's something we may not have seen before. So both the b and c terms are negative. So how would we go about factoring this equation? So the first thing that we always have to look for, remember, is common factoring. So that's the very first thing. So first we're going to common factor. So looking at that trinomial, we need to figure out the greatest common factor. So the greatest thing that we can divide out of all three of those terms. So I can see right away I can't do an x, right? Because my c doesn't have an x on it. So I'm going to look at those coefficients. So 2, -4, and -16. So the largest thing that I can divide 2 by is 2, right? It only divides by 1 and 2. So I just have to make sure my -4 and my -16 can also be divided by 2. They can, so I know that is the common factor that I'm going to take out. Okay, and I can't take anything larger than 2 because the first term only has 2 to give. Okay, so 2x squared divided by 2 is x squared. -4x divided by 2 is -2x, and -16 divided by 2 is -8. Okay, the next thing that I need to look for when I'm going about factoring this is to see if I can keep going. Okay, so to keep going is when I would create my chart, right? Where I have to multiply to get my c value and add to get my b value. So I'm looking for two numbers that both multiply to give me -8 and add to give me -2. So I know it's not going to be 8 and 1, right? Because that's never going to add to give me -2. But I'm thinking it might have something to do with 4 and 2, right? 4 times 2 gives me 8. And once I apply a negative here, I will be able to get that -2 on my left-hand column, or my right-hand column, sorry. So I know that one of these has to be negative, right? Because 2 times 4 gives me +8, but I need it to be -8. So I just have to play around and decide which of these I need to put the negative on. Okay, so if I put the negative on 2, that would mean I would have 4 plus -2, which is the same as 4 minus 2, which would leave me with +2. But that's not what I need to get. I need to get -2. So if I put the negative on the 4, I have -4 plus 2 does in fact add to give me that -2. So when I'm continuing factoring here, remember I leave that common factor out front, and then I have x plus 2 and x minus 4. Okay, and now this is fully factored. Okay, so let's try a couple more of these factoring examples just to kind of hopefully bring that all together for you. Okay, so it says try factoring these. So the first one is 3x squared minus 6x minus 9. So again, the very first thing that we need to do is we need to try to common factor. So again, I can't take out an x out of 9. So I know that I have to look for the coefficients. Look at the coefficients. So I have 3, 6, and 9. So right away I should think, okay, awesome, I can factor out that 3. And again, remember, you're always trying to factor out that value in front of your x squared term. So I am going to factor out 3. That means I'm dividing all three of those terms by 3. 3x squared divided by 3 leaves me with x squared. -6x divided by 3 is -2x. And -9 divided by 3 is -3. Okay, the next step I want to do is my t-chart. Okay, so I'm looking for two numbers that multiply to give me -3 and add to give me 2. Those are pretty small numbers, right? So, and 3 is a prime number. So the only thing that multiplies to give us 3 is 3 and 1. I know that there has to be a negative on one of these because I need to multiply to give me -3. Okay, I'm going to put that negative on the 3 because when I do that, I will be able to add to -2, right? -3 plus 1 gives me that -2, which means those have to be my factors. Don't forget to leave your greatest common factor out front. And then you're factoring this trinomial, so that's going to turn into x minus 3 and x plus 1. Okay? Same thing for the second example, right? The first thing that we want to always look for is common factor. Again, I see that there's no x on my last term, so I can't common factor out x. 2, 12, and 16 all divide by 2, so I am going to factor out that 2. Remember, factoring out just means dividing each of your terms by that number out front. So 2x squared divided by 2 is x squared. 12x divided by 2 is 6. And 16 divided by 2 is 8. And sorry, I forgot the x. This should be 6x plus 8. Okay, again, once we've done that, we can't just assume we're done. We have to try to use our t-chart. So I need two numbers that multiply to give me 8 and add to give me 6. So I know that's not going to be 8 and 1, right? That'll add to give me 9. But if I do 8 divided by 2, that's 4 and 2, and those will indeed add to give me 6. Again, making sure I'm leaving that 2 out front, I have x plus 4 and x plus 2. Okay, last factoring example here. So again, the first thing I'm going to do is look for a common factor. So I have 2x squared and -6x as my two terms. I can see there's an x on both of those. So I know I'm going to be able to take out an x. I also know that 2 and -6 are divisible by 2. So I'm going to common factor out 2x. Again, common factoring just means divide both of those terms by what's out front. So by that 2x. 2x squared divided by 2x, I'm left with an x. -6x divided by 2x is -3. Okay, and I can't factor this any further, right? Because I don't have a trinomial. Okay, so that was just a quick review of factoring. So now it says, thinking back to 2x squared minus 4x minus 16, what is the y-intercept? Okay, you have to remember the y-int is our c value. Okay, so that means our y-intercept is at 0, -16. Okay, and we're going to continue with that concept. Like I said, this one's a bit longer. We've got 3 pages here. I will pull up the next one. Okay, so it says, what does the common factor represent in the factored form? Oops. Okay, there we go. So the common factor, so that's what we're common factoring out. It's always the a value. Okay, so in that last case, on that back side, our a value was 2, right? We were common factoring out the 2. Okay, the next question is, okay, that's fine. The a value is your common factor. What is the step pattern? Okay, well, remember to find the step pattern, we just take that original 1, 3, 5 and multiply it by our a value. So that means our step pattern is 2, 6, 10, etc. Okay, now it's asking us what are the zeros? Well, again, you'll be able to kind of flip back to this. But we're looking at 2x squared minus 4x minus 16. So that was the very first thing that we factored. So we got that our factors were x minus 4. So we're going to set that equal to 0. And x plus 2 equals 0. Okay, and that should be easy to remember because they're called zeros, right? So you just have to remember that you have to set them equal to 0 and solve for x. So these are easy to solve, right? We're just moving that value over the equal sign. Okay, so our zeros in this case are going to be 4, 0 and negative 2, 0. Okay, next it's asking what is the axis of symmetry? So remember, to find the axis of symmetry, we add those two values together and divide them by 2. So 4 plus negative 2 is the same as 4 minus 2. So we have 2 over 2. So our axis of symmetry is 1. To find the optimal value, as we learned in the last lesson, we have to sub that 1 in for x and solve for y. So I'm just going to rewrite out that equation so that it's in front of me. And then I'm going to replace the x's with 1. So I have 2 times 1 minus 4 minus 16. 2 times 1 is just 2, right? So 2 minus 4 is negative 2. Negative 2 minus 16 is negative 18. Okay, so it's asking us what is the vertex. Again, we don't have to solve anything, right? It's just coming from these two values. So our vertex, axis of symmetry was 1. Optimal value was negative 18. Okay, and now it would like us to graph this. So it's actually worked us through all of the information we need to graph this, right? So the first thing we're going to do is graph those zeros. So we had zeros at 4 and negative 2. So negative 2 would be here, and then 1, 2, 3, 4 would be there. Okay, the next thing we have to graph is our vertex. So our vertex is at 1, negative 18. So I've already counted these down. Believe that there's 19 squares, so negative 18 would be there. Okay, and you can check that if you'd like. So this isn't really enough points for me to confidently graph this parabola, so I'm going to use my step pattern to graph a couple more points, right? And I know that my step pattern is 2, 6, 10 because my A value was 2. So that means I need to go over 1, up 2, put a point. Over 1, up 2, put a point. Over 1, up 6, 1, 2, 3, 4, 5, 6, put a point. Same thing on the other side. And then I need to go over 1, up 10, which again, I'm going to just trust that this is 10. I already have those points plotted. This is plenty of points for me to draw my parabola confidently. So I am going to connect, geez, that's ugly. Connect my dots as best as I can to make that U shape. Okay, and as you can see, given that information, we graphed the parabola. And again, this is a review. We did learn that in the last lesson. So we have one more page here. We're not actually going to do all of the examples because the first one is very similar to what we just did. So it says here, oops, hello, can I zoom? Oh, graffiti, there we go. It says we can use trinomial factoring to change standard form to factored form to answer many different types of questions. Okay, so this first one I'm going to have you do on your own because it's very, very similar to the question we just did on the other side. Okay, where we factor, we determine the zeros, the axis of symmetry, the vertex, the step pattern, and graph. Okay, so I want you to go ahead and do that one on your own. Number 2, I also want you to do on your own. So it says, imagine you had a quadratic relation in standard form. What steps would you take to make an accurate graph of the parabola? So we went through that step by step on the last slide, but also in the last note, so you should be able to answer that one as well. Okay, what I'm more concerned about is this word problem. Okay, so this last one, number 3, I just want to do one of these together so you have kind of a basis to go off of when you're doing the homework. So it says a ball is thrown upwards. Its height is described by the equation h equals negative 5t squared plus 20t, where h is measured in meters and t is measured in meters. So h is your height and t is or sorry, t is measured in seconds, not meters. T is your time in seconds. Okay, so this is the equation. Picture yourself, I'm sure everyone's thrown a ball at one point in their lives. Picture yourself throwing a ball. This is the equation that is going to describe it. So part A asks us to common factor our equation. And this is going to be kind of hard for me to fit all of this in. So bear with me given the space that I have here. Okay, so common factoring. So that's easy, right? We just have to look what is common between negative 5t squared and 20t. So again, thinking of those as like separate entities, right? So the first thing I can see is that there's a t in both. So I know right away, okay, I'm going to take out a t for sure. Okay, so whoops. Then I am looking at those number values. So remember, the goal is to always take out the a value. So that's the number in front of your squared term. So I know that 20 will divide by negative 5 evenly, so I'm going to factor out that negative 5 as well. Okay, remember when you're common factoring, all you're doing is you are dividing each of those terms by what you have out front. So negative 5t squared divided by negative 5t, all I'm left with is a t. Okay, 20t divided by negative 5t is negative 4. Okay, so that is part A. That is me common factoring that equation. Part B says, how high is the ball at 0, 1, and 2 seconds? So in order to solve that one, it's actually asking you to sub t equals 0, t equals 1, t equals 2, right? It's telling you the time is 0. Okay, 0 seconds have passed. How high is the ball? 1 second has passed. How high is the ball? 2 seconds have passed. How high is the ball? So all you're going to do is you're going to replace t with these values. So I will show you one of them, and then I'd like you to try to do the others on your own. Maybe I'll show you two. We'll see. So let's start with t equals 0. So h of 0, and this is just kind of proper form here. So h, the height, what this is saying is the height at 0 seconds is equal to negative 5 times 0 squared plus 20 times 0. So 0 squared is 0. 0 times anything is 0. So here we have 0 plus 0. So our height at 0 seconds is 0. Okay, so the ball is basically on the ground at 0 seconds. Okay, at 1 second, that means we're just replacing t with 1. So negative 5, 1 squared is 1, right? So negative 5 times 1 is negative 5, and 20 times 1 is 20. Okay, so that means after 1 second, the height of my ball is 15 meters. Okay, so to figure out how high the ball is at 2 seconds, you are going to just simply replace t with 2, okay, and solve in the same way that I did for both of those. Okay, so I'm leaving that last one up to you to practice on your own. So that one there. So t equals 2. All right, moving on to C here. So it says, using the factored expression, find the time when the ball hits the ground. So in part B, it told us the time and it asked us for the height, right? This time, it's asking you to find the time, okay? And it's telling you the height. It's not explicitly telling you the height, but it is telling you, find the height when the ball is on the ground. Okay, if anything is on the ground, that means the height is 0, right? So this hint says, find when h is 0. So in order to do that, we are going to set our equation equal to 0, right? So we're replacing the h. So we now have, and I'm going to do it down here, we have 0 equals, and it wants us to use our factored form. 0 equals negative 5t times t minus 4. Okay, So in order to solve this, what we're actually going to do is we're going to set each of these factors equal to 0. So it's going to be the same way that we solved for our roots, right? Because if you think about it, if you were to think about the graph of this, obviously when it's at 0, it's going to be on that x-intercept. So now I have negative 5t equals 0 and t minus 4 equals 0. And I'm simply going to solve for t. So in order to get rid of this negative 5, I need to do the opposite operation. Those will cancel. 0 divided by anything is 0. Over here, opposite operation is to add 4. So I get that the going to be on the ground at 0 seconds and 4 seconds. Okay, so assuming they mean after I've thrown it, I could say that that's going to be at 4 seconds. If I don't want to assume, if I want to just play it safe, I'll say therefore the ball is on the ground at 0 and 4 seconds. Okay, so I set my equation equal to 0, which means I'm setting my two factors equal to 0. Okay, so last part here, part D, it says use your answers from C to find the maximum height of the ball and where it occurs. Anytime you see the word maximum, okay, or minimum, that means it's asking you to find the vertex. Okay, because the maximum height is your optimal value. And the time that you get to that optimal value is your equation of symmetry. Okay, it's your x-coordinate of your vertex. So we are simply going to use our x-vertex formula to figure out when it occurs. So remember, we take our two values from over here, we add them together, and divide by 2. So my x-vertex is going to be 2. To figure out what the maximum height is, so that this, just to be clear, this means that it's occurring at 2 seconds. Okay, that's when it occurs. To figure out what that actual height is, just like before when we were graphing, to find the vertex, we had to sub in that value into our equation and solve for y. So I have negative 5 times 2 squared plus 20 times 2. Okay, and I'm simply just going to solve using BEDMAS. So I have negative 5 times 4 plus 40. So negative 20 plus 40, y is 20. So that means that my maximum height is 20 meters and it occurs after 2 seconds. So again, stating that is always best. So max height is 20 meters, which occurs after 2 seconds. Okay, so just by given that equation, we are able to figure out all of this different information. So this is how we can apply this information that we've learned in this unit to different word problems. So again, the word problems tend to be the trickiest, so make sure you take a good amount of time to look at that homework, look at the review before completing your assignment. So this is the end of the last lesson of Unit 3.